Okay, so this is sequences for chapter 7. And so um, there are two types of infinite sequences. That's what we're going to talk about today. The two types of infinite. And that's an I right there, right? Two types of infinite sequences. Let me clean that up. Two types of infinite sequences. All right, so the first one is what's called a convergent sequence. C-O-N-V-E-R-G-E-N-T, a convergent sequence. Okay, so it's infinite, right? We know what those are. We talked about those already. Infinite sequences are those that have the three dots. They go on forever, right? So infinite sequence. So how do you know if it's convergent or the other kind? You'll know it's convergent because of this. As n increases, and we already know what n is. N tells you which number of the sequence, right? If n is 1, it's the first number of the sequence. N is 5, it's the fifth number of the sequence. If n is 100, it's the 100th number of the sequence, right? So as you increase n, as you keep getting bigger and bigger, more numbers down the sequence, what will happen is it approaches a real number. It approaches a real number. Okay, so what does that mean? All right, look at the example right here. And you know what? Let me put my screen up so I can focus your guys' attention where I need to focus it. Okay, so if you look at example B, or A example here, B sub n. So we've got this sequence. And as we know, there's when n is 1, and we're 6.8, and then we're 6.4, and then we're 6.2, and 6.1, etc., all the way down to where I have what, n sub 8. So the eighth term is 6.0625. All right, so that should be enough to give you an idea of what this sequence is approaching. So I'm going to write underneath, it is approaching and what is it approaching? Anybody? John? What real number? It is approaching 6. You notice the decimal part is getting smaller and smaller. And so this is approaching 6. Okay, it's a convergent sequence. It's approaching a real number. And we've already talked about the real numbers and what they are, and they involve all the different number sets. Okay, so let's keep going. The real number that the sequence approaches is called the limits. And this is the whole reason I'm even teaching this lesson. Because in our country today, they're really beefing up the math of all students. The concept of limits is usually a concept that you learn in calculus, but these days you're getting it earlier and earlier, and they want students now in Algebra 1 to understand what a limit is. And so the real number that it approaches is the limit. The sequence can't go past it, right? It can't go past that number. All right, so what's the notation? You can see you got the script LIM, short for limit, and then underneath you have n. Remember, n is which number of the sequence. So as n approaches, and then it'll have an infinity. Oh, that's an ugly infinity. That's what happens when you try to do it small. That one's not much better. Third time's the charm. That one's not a whole lot better. Hard to write it on the screen. So the notation is the limit as n approaches infinity. And we'll do an example of that here in a minute. Now, if we were using this example right here, we would say it equals 6, right? If we use the B example. Okay, so let's go through and see if we can make sense out of this. So here we got a second example. Let me just focus you on what I'm talking about. Here's our sequence right here, right? And it tells us the rule how to figure out each term of the sequence. Down here, we're asking for the limit, right? As n approaches infinity, the arrow, you say, approaches. So what's the limit as n approaches infinity? Well, we got to figure it out. So what we're going to do is we're going to go through and figure out some of the q's. What is the first term of this q sequence? Well, we've done this before. You just stick a 1 in where the n's are, right? Right? So 3 times n, so 3 times 1 plus 1 over 4 times n, so 4 times 1, right? And so now we end up with 4 over 4, and we all know that's a 1. So what was the first number of our sequence? It was a 1. All right, so q sub 10. I'm skipping. I mean, we could do the second term, third term, fourth term. It's going to take a long time. And remember, where do we want to end up? We want to figure out infinity. So we want to get way down there. So I'm just going to skip the 10. So I'm going to go 3 times 10, right? 3 times n plus 1 over 4 times n, or 4 times 10. So what do you get for this fraction, Wesley? 31 over 40. So I'm going to take that on my calculator and punch that in my calculator because the decimal is going to help me to see what's going on here. Because the decimal will just help me to understand it better. Anybody got the value decimal? John? 0.775. Okay. All right, we see we're getting smaller than 1, aren't we? Well, let's continue. I went all the way to 100. So again, 3 times 100 plus 1 over 4 times 100. So what fraction is that? 301 over 400. So divide that out in your calculator. And we'll go to 5 decimal places. Matt, what do you got? 0.75, is it 25? Everybody agree? Okay. 0.7525. All right, let's go 1,000. And you see, I'm just getting bigger, right? I'm heading to infinity. And you don't even have to do all of these. I'm just trying to get you an idea of what's happening with sequence. Okay, so now it's going to be, can you almost tell the fraction already? 3,001 over 4,000, right? 3,001 over 4,000. Somebody punch that in. Justin, what do you got? 0.75025. Okay. Are we beginning to get a read on what's going on? Let's do a million. What would the fraction be? Anybody do the fraction in their head? Raise your hand. Anybody, fraction in your head? Come on, somebody besides Kyle. Come on, somebody besides the 4 people. Sam? 3,000,001 over what? Over 4 million. So go ahead and punch that into your calculator. 3,000,001 divided by 4 million. I need somebody to answer that has not answered yet. So volunteer, I'm going to call on you. Somebody that hasn't answered a question yet, raise your hand and give me what that decimal is. 3,000,001 over 4 million. Quinn? 0.7500025. Okay. All right. So here now is the question. Don't say anything out loud. That should give us enough to figure out the limit. Can you tell where the sequence is going? If you can tell where the sequence is going, then you can write the limit. If you can't, do 10 million, do 100 million, do a billion, do a trillion if you can't see. The bigger the number, the closer you'll be to the limit, right? And it'll help you to understand. So, Gabe, what do you think the limit is? I was hoping you'd be thinking the whole time I was talking. Adam? 0.75 is the limit. 0.75. Really important, guys, that you're thinking as I'm asking the questions. If you're not thinking in this class, you are not learning, all right? And maybe you are, you don't know what to think, but try to think every step of the way so we can figure out what's going on here. All right, I need to raise this. Okay, so that's the first one. So here we've got a second one, D. And this one, I've shown you what? The first, second, third, fourth, fifth, sixth, seventh, eighth. I show you 9 terms, right? 9 terms. Where would you guess this one's going to end up? And this is a little bit of a guess, but if you look at what's happening, you can figure out even what the next number is going to be and where this thing is heading. So what would be the limit of this one? By the way, what happens to get from a 9 to a 3? What would you do to the 9? What happens if you divide the 3 by 3? What do you get? What if you divide the 1 by 3? What do you get? What if you divide the 0.3 by 3? The 0.1 by 3, what do you get? Oop, I'm missing a point. No, 0.03, yeah. And then what if you divide 0.03 by 3? What do you get? 0.01. And you see everything's divided by is divided by 3. And so it just keeps going that way. So where do you think we're going to end up, Wesley? We'll get there, but we'll get past that. Gabe? We'll get there, but we'll remember we keep going. This is an infinite sequence, so it'll keep going past there. Where are we going to end up, John? Oh, we'll hit a limit. We'll keep getting closer and closer to this number, but we'll never get lower than this number. This is where this thing is heading. Josh? This one, the limit is 0. If you keep dividing by 3, you're going to keep getting closer and closer to 0. You know, at one point you're going to have like 0.0000000000003, and then you're going to divide by 3, and you're going to have 0.0000000 at a ball game 1, right? And then you divide again by 3. You just keep getting, you get more zeros, and you're getting closer and closer to 0. All right, I want you guys to figure out the limit of this one. I'll give you a little bit of help though. Do z sub 1, do z sub 100, and do z sub 1,000,000. And that should allow you to know where this thing is heading. So see if you can figure out the limit. All right, if you're watching on video, I would pause the video right now, and then you can resume. All right, once you do those 3, go ahead and write in your limit. Who wants to go for it? Come on, somebody else. I'm going to start calling on you. Gavin, what do you think? What'd you get for z of 1? 0.3 repeating? I don't think so. Let's see, you get a 1 over a negative 2. It's negative 1/2, right? Z of 1? Okay. Gavin, what'd you get for z of 100? Okay. All right. Leanna, what do you think the limit is? Okay, come on. All you're doing is subbing in, folks, and using your calculator. You're just dividing out with the calculator. Jeffrey, what do you think the limit is? 0.2? I don't think so. I like the 2, but I don't like the 0.2. Ethan, what do you think the limit is? 2? I like the 2, but I don't like the rest. Arlette, what do you think the limit is? -1? I don't think so. I don't think so. Tommy, what do you think the limit is? How can you guys not be done yet? I can't comprehend this. Okay, just pause. Look, you're looking at this, right? I'm going to do the second one. Look how long it takes to do the second one. 3 minus 2 times 100 over 100 minus 3. That's negative 197 over 97. Hit it on your calculator. What does your calculator say? Negative 2.0309. Okay, that was 25 seconds. Now do it with a million. Anybody have the decimal for a million? Justin? I don't think so. Kyle? I don't think so. All right, hold on. Let's do it again. 3 minus 2 times a million over 1 million. Is that a million? Minus 3. What's 2 times a million? And it's a negative 2 million, isn't it? What's a negative 2 million and a positive 3? Negative 1,999,997. What's a million minus 3? 999,997. Divide that out, and what do you get, Gabby? 3, right? I got 1, 2, 3, 4, 5, 6 zeros, and then a 3. Okay, folks. Is it 5? Okay. So let's look. Negative 1/2. Negative 2.0, what was that, 0309? Now negative 2.000003. Where are we heading to, folks? Negative 2 is the limit. All right, I can't. You guys have calculators. You have calculators. Look, just honestly, if you can't calculate that, I can't help you. I mean, I'm trying to teach you how, but I can't teach you how to punch 2 minus 7 on a calculator. All right, you got to learn that on your own. So get it figured out. But that should, I mean, you got calculators. That shouldn't have taken that long. All right, let's go to the back. Let's go to the back. All right, so that's the first kind, convergent. Convergent. The second kind is divergent. Divergent. Convergent converges to a limit. Converges means like if two people were converging on the same thing, maybe there was, what's something extremely desirable to have? Your what? J's. What are J's? Their shoes. What if two guys were a little bit apart and were heading for the J's? They would be converging. Okay. At lunchtime, all of the classes that have lunch converge on the lunchroom. What happens with a convergent series? It's heading toward a limit. What happens with a divergent sequence? As n increases, it approaches its divergent. It goes in 2 directions. And this is an or. So they head, it approaches negative infinity or positive infinity. There's 2 possibilities on a divergent series. Again, it's an infinite sequence. It's divergent if it head toward negative infinity or positive infinity. Divergent sequence. Okay, so here's an example of the first one, a sub n. First term 1, second 7, 13, 19, 25. So you can see the direction this thing is. It's heading toward what? Say it if you know it. Positive infinity. And usually you don't need to write the positive for positive infinity. So this thing's approaching positive infinity. The second one, you have the rule. They aren't showing you the numbers of the sequence. Let's see if we can figure them out in our head. The first one will be a negative 3 plus 1. That would be a negative 2. Do you agree? When you use 1 for n? What do you get when you use 2 for n? Say it if you know it. Negative 5. Good, Justin. You follow what we're doing? What do you do? What do you get when you use 3 for n? Come on, think, look up, right? Negative 3 times 3 is negative 9 plus 1, negative 8. What do you do with 4? By the way, what's happening between every number of the sequence? It's getting 3 less, right? So negative 3. So the next one's got to be negative 14 dot, dot, dot. Where are we heading? Negative infinity, right? Those are two examples of divergent sequences. I threw this one in to get you practice with negative exponents. So we're gonna do this one and I'll show you the work. I don't know that you'll ever get any of these, but I wanted to practice you with your negative exponents. All right, so let's do k sub 1. All right, k sub 1. So we're going to do the negative 2, the minus, and where the n is, we're going to put a 1 in, yes? So k sub 1 is negative 2 to the negative 1. What is 2 to the negative 1? What is, that should be black. What is 2 to the negative 1? You should all know this. We've done negative exponents. What is it? Brother. What is x to the negative a? Say it if you know it. 1 over x to the a. Will you please do that to the 2? What is 2 to the negative 1? 1 over 2. K sub 1 is negative 1/2. Now you can see why I chose this one. All right, let's do for time's sake, let's go k sub 10. Negative 2 to the negative 10. So this is negative 1 over 2 to the 10th. Now you're going to have to use your calculator here. Don't worry about the negative. We know our answer is going to be negative, correct? Okay. Punch this in. Punch in 1. Hit your division button. Punch in 2, the base. And you remember your exponent button? It's either the caret button or x to the y or y to the x. And then punch in the 10 and hit equals. And remember, it's negative, right? Because we had a negative out in front. So this is negative 0.0097562. 63. Mine says 562. Yours must round off your last digit. You might have more digits. Okay. All right. So here's what I just found. We started at negative 1/2. We are now at negative 0.000. I think we're heading toward what? No, I don't think so. Okay, if you can punch this, punch in 1 divided by 2 to the millionth. 1 divide by button, 2 to the millionth. Oh, okay, let's go 2 to the 50th. 1 divided by 2 to the 50th. See if it'll handle that. Okay. So listen. Shh, listen. Will you listen? Good, because if not, I'll make you write, and that'll help you listen. So this is point, how many zeros? 15 of them, and then 8881784. So what are we approaching? What are we approaching? This thing is approaching 0. So this is actually a convergent sequence because it's approaching a real number, isn't it? It's not getting bigger and it's not getting smaller. It's heading to 0. This thing is heading to 0. So that was actually a convergent. All right, remember, divergent, head to negative infinity or positive infinity. This thing's heading to 0. And one other note, divergent sequences do not have limits. Only convergent have limits because they go to a number. This thing will not go past 0. It's a negative number heading to 0, but it won't go past 0. 0 is its limit. Okay? Divergent sequences do not have limits. All right, that's it for today. Your work is page 294, 1 through 3, 5 through 7, 9 and 10, and then the video 1 through 3, 5 through 7, 9 and 10.